Assalamu alaikum ladies and gentlemen, welcome back to another lecture of digital signal and processing. This is Khurram Aziz 16DE59, and in this lecture we will discuss some of the basic operations that a system can perform on a signal. The first is called shifting. Shifting is basically motion or moving the signal on the time domain by a specific unit, and its example is, for example, if y of n is equal to x of n minus 3, then this signal is being shifted and it is being delayed by 3. So if the signal starts from 0 here, it has an amplitude of 1 at 0. At 1 it has an amplitude of 1. For example, this is our x of n. Now when we apply y of n, when the signal passes to the system, this will become a delay will be added. So in order to delay, we will have to move this to the right hand side by 3 units. So it will start from 3. Here's a 0, 1, 2, 3, 4 and 5. So this is known as shifting of the input signal. Now scaling is basically of two types. It has basic two types: time scaling and amplitude scaling, and both of these are quite different from each other. So what is the basic definition of scaling? Scaling is the compression or expansion of signal in time. It is the compression slash expansion of signal in time domain, in time. So we have discussed, it has two types: time scaling and amplitude scaling. I will give the example of both. First of all, time scaling. If a function y of n or a system does this to an input signal, this is where the time scaling is done. This will tend to compress the signal or expand it. If it's a division factor, then it will expand the signal, and if it's a multiplication factor, then it will compress the signal. The other type is the amplitude scaling, and in this scaling, I'll give you an example of this type of scaling. We have tan of x, and this only meddles with the amplitude, whilst this is responsible for compression and expansion. This increases the amplitude and decreases the amplitude, but this is the compression and expansion. For example, x of n is -2, 0, 2, and this is the 0th position. So what will happen here is y of 0 will be equal to x of 0, which will be equal to 0, but y of 1 will be equal to x of 2, which is 0, because we have nothing on the 0th position. And similarly y of -1 will be equal to x of -2, and this would also be 0. So this, what has this done, it has reduced our signal only to the 0th position. It has compressed the signal. Now if we take the example, in this case y of n will be equal to, the resultant will be equal to 0 on the 0th position. Just this will remain. The other one are discarded because the signal have been compressed and these have become obsolete. Now when we take the example of amplitude scaling, what this does, this will increase the amplitude, will increase these factors over here. So it's just a simple multiplication. We will have 20, 0, -20, 0 and 20. This is on the -1 position, 0th position, and the first position. Now the second thing, or the third operation which a system can perform, is called mirror or flip. This is basically creating a mirror image of the signal. So if we have this signal, suppose this is x of n, 0, 1, 0.5, -0.5, 1, first, second, third and fourth position. Now when we apply mirror operation or flipping operation on this input signal, this will tend to look like, there are two types. There is a positive, this is denoted by x of n is negative of n. This is called, or this is what is known as flipping. So what this does, the amplitude will remain the same, only the position will change. This is the 0th line, 0.5, 0.5, 1. Here -1, this will go on -1, -2 up to 0.5, oh, up to 0.5, -3, and at -4 it will reach -1. So this is basically known as mirror or flipping operation. Now we shall see some examples in which we will apply these three operations. Now consider the example. We have y of n, which is the system function, transfer function, which is equal to x minus 2n plus 3, and we have x of n, which is equal to 1 2 minus 1 2 0 1 1 and 3. This here is the 0th position. I'll double underline it. Okay, now we will perform in this order, this particular order. First we'll shift, and this order is very important in order to obtain the right results. This has been proven through scientific experimentation, so this order is quite important. Shifting is applied first, then flipping or mirror, and then scaling. Okay, first of all, shifting.